Chapter 6.4, Applications of Linear Systems. Your objective for this lesson is to choose the best method for solving a system of linear equations. Okay, before we get started, we're going to talk about when the best time to use each method is. If you want to see the visual display of equations, then you probably want to use graphing. So when you want to see, or when you want a visual display. Or if you just have to estimate, you can use graphing because it's not an exact thing unless you have a computer. All right, substitution would be better if one equation is already solved for one variable. So if it says x equals or y equals, that's when you want to use substitution. And then elimination would be better if the coefficients are the same or opposites already. Or when all else fails. Like elimination's probably your last resort. If substitution and graphing won't work, then you're going to use elimination. Okay, so example 1, finding a break-even point. So a fashion designer makes and sells hats. The material for each hat costs $5.50. The designer spends, or the hat sells for $12.50. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? So what we want to do is we want to write equations to figure out how much she's spending and how much she's making. So to figure out how much she's spending, that's going to be what y equals. And she's spending $5.50 per hat plus $1,400 on advertising. Then we want that to be the same as what she's making. So we're gonna make her expense y. Then we're gonna make her income y. So what she's making is gonna be $12.50 per hat, and that's her only income. Oh, let's do h like I did before. So her expense is going to equal $5.50 per hat plus $1,400, and her income is going to be the same thing, and it's going to equal $12.50 per hat. For this one, the best method would be substitution because both equations are already solved for y. So what we're going to do is take what y equals here and set it equal to what y equals here. So we're going to do 550h plus 1,400 equals 1250h. Then we just solve for h. And we get 1,400 equals 1250 minus 550 is 7h. So we're going to divide both sides by 7. And we get 200, which means she would have to sell 200 hats to break even. All right, example 1. The puzzle expert wrote a new Sudoku book. His initial costs are $8.64. Binding and packaging each book costs 80 cents. The price of each book is $2. How many copies must be sold to break even? Do the work yourself, because if you don't, you're going to get the question wrong if you don't show your work. But if you will pause the video and do the work and then come back after you're ready, I will give you the answer. All right, guided practice 1, you should get 720 books. If you didn't, you need to go back and fix your work and figure out what you did wrong. Example 2, Identifying constraints and viable solutions. The local zoo is filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? So we are going to fill, let's see, total in the tank for the first one is going to be 50 plus 10 per hour. And total in the second tank is going to be 29 plus 3 per hour. So since they both already equal T, let's just set them equal to one another, just like the last question, and solve. So I'm going to subtract 3H from both sides. Okay. And we get 50 plus 7H equals 29. Subtract 50 from both sides, and we get 7H equals negative 21. We divide both sides by 7, you get H equals negative 3, which means it has to fill for negative 3 hours. Is that possible? No, because you can't have negative 3 hours. So they have no viable solution. No viable solution. Like the solution we got works just algebraically, but for the real world problem it doesn't work at all, so it's no viable solution. Example or guided practice number 2. Go ahead and do that one. Show all your work. These will never have the same amount of water either, but show your work will be right. There's no viable solution here, but see how I had no viable solution here and I had work? You're going to show all of your work, but just know at the end that you're going to get negative 2 hours, and you can't fill it for negative 2 hours, so there's no viable solution. All right, example 3. Solving a wind or current problem. Traveler 1 flies from Charlotte to Los Angeles at the same time. Traveler 2 flies from Los Angeles to Charlotte. The airspeed of each plane is the same. The ground speed of Traveler 1's plane is 495 miles per hour, and the ground speed of Traveler 2's plane is 550. What is the airspeed and what is the wind speed? So we have things called headwinds and tailwinds when you're talking about flying from east to west. If you're going from the west coast to the east coast, you have what we call a tailwind, and it takes your airspeed and it adds the wind speed to it. So here's your airspeed. That's how fast the plane is flying. And then it adds the wind speed to it. So it's like it's pushing you. And that gives you the total ground speed. But if you're flying east to west, so from like North Carolina to Los Angeles, you have a headwind, which means the wind's blowing directly to you and it slows you down. So your airspeed is made up of your wind speed and your ground speed. And you subtract your wind speed from your airspeed, and that'll give you your ground speed. But anyway, so our equation is going to be for Los Angeles to Charlotte, we are going to take our airspeed, which is the same, so A, plus our wind speed, W, and that's going to give us our ground speed, 495. Wait, Traveler 1 flies from Charlotte to Traveler 2's flights from LA to Charlotte. So we're Traveler 2. So that's going to give us $550. Okay. Then, for Traveler 1, we're going to take our airspeed, which is the same, minus our wind speed, which is the same, and that's going to make up our 495 miles. Okay, the best method to solve this would be elimination, because airspeed, or the two wind speeds, are going to cancel each other right here. So that's going to give me 2A, that cancels, and I get 9, so I get 1,045. Divide both sides by 2, and I get that both planes' airspeed is 522.5 miles per hour. They want to know the wind speed, so we're going to take this and plug it back in here. So 522.5 plus wind speed gives me 550. Then if you just subtract 522.5 from both sides, you get 27.5. So airspeed is 522.5. Wind speed is 27.5. Okay, guided practice number 3. I'm going to get you to do this on your own as well. We just did an example, so if you need help, then just go back and look in the video. But if you'll do it, I will give you the answer after you resume the video. Alright, the answer for the rowing speed is 3.5 miles per hour. And the answer for the current, the speed of the current, is 1.5 miles per hour. Okay, have this ready tomorrow to be checked and be ready to take a quiz.